Tools, Reporting, and Analytics using the Autonomous Data Warehouse. When you have completed this video, you will be able to describe how to use ADW with third-party software, describe how to build analytic views, explain how to use Oracle Machine Learning, and finally, you will be able to explain how to install and configure Oracle Analytics Cloud and Data Visualization Desktop, and how to connect them to Autonomous Data Warehouse Service. Let's get started. As was covered in provisioning and connectivity, here are some of the supported connections to the Autonomous Data Warehouse. You should already know about the credential wallet file from the section on provisioning and connectivity, as you will be using it in the various types of connections we will cover. The Oracle Call Interface, or OCI, Open Database Connectivity, or ODBC, and Java Database Connectivity, OCI, all have specific requirements in order to connect to the Autonomous Data Warehouse. First, you will need the credential wallet file and have it unzipped, as the Oracle Net Services cannot read the zip file. In your SQLnet.Aura, you need to set the wallet location variable to point to the wallet file. When the wallet underscore location is set, then Oracle Net Services allows the application to use the wallet file transparently. Also, the TNS underscore admin environment variable needs to point to the credentials file. Both of these will allow the connections to use the same specific configuration files inside of the wallet to connect. The Oracle Client 11.2.0.4 or higher is required in order to have the right drivers to connect to the Autonomous Data Warehouse. .NET application requirements vary depending on how the application is deployed. If you're using Visual Studio, you will need to download and install ODT and managed ODP.NET files. If you're using NuGet, then you can use NuGet Package Manager to download and install the Manager ODT and ODP.NET files. If you're using unmanaged ODP.NET, or the Oracle Universal Installer version of Oracle Data Access Components, then you will need to download the appropriate ODAC files instead of the ODT files. Once the appropriate files have installed, then you will need to set the wallet underscore location in the SQLnet.Aura to point to where they extracted the wallet file. Depending on the version of Windows, you may need to enable TLS 1.2. Depending on your JDBC or UCP connections are set up, you will need to do some of the following. You will need JDK 8 or higher, specifically the JDK 8U161 or higher installed. Also, there are specific jar files needed to be in place. If you're using JDBC Thin Driver 12.2.0.1 or JDBC 8.jar, then you will need the 12.2.0 UPC.jar. If you're using the patched JDBC Thin Driver 12.1.0.2 or JDBC 7.jar, then you will need the 12.1.0.2 UPC.jar. Once you have the correct drivers installed, then some configuration is needed. If the TNS underscore admin variable is set, then copy the OJDBC properties file from your wallet directed to the TNS underscore admin directory, and set the Oracle.NET wallet location in the OJDBC properties file. This will allow you to just use this service name in the JDBC URL. If TNS admin is not set, then you would need to specify TNS admin as part of the URL and point it to your wallet directory. What this allows is for you to specify a service name that is in your TNSNames.Aura instead of having to fully spell out all the connection information in the JDBC URL. If you need to use the HTTP proxy to get to your Autonomous Data Warehouse, then you will need to edit the TNSNames.Aura file and add the parameters HTTPS underscore proxy and HTTPS underscore proxy underscore port. This will also require a JDBC Thin Client 18.1 or higher. Let's get started with building analytic views. Now that we have looked at how to connect applications to the Autonomous Data Warehouse, let's see how we can leverage the ADW using analytic views. Oracle Analytic Views are new as of 12.2 and provide some unique functionality. Analytic views allow the complex business models to be viewed into a view. This greatly simplifies queries while improving performance. Analytic views allows for business logic to be stored in the database instead of across a variety of tools, giving more consistency to your reporting. It allows for simple select statements against views instead of a massive complex query. Also, since it's stored in the database, the Smart Query Transformation Engine can help with the performance of the view. Here you can see just how powerful the analytic view can be. Notice it's just not tables in your database that can be used in Analytic View. The Analytic View can be built over a variety of sources, allowing for simple SQL and MDX access to very complex datasets. Your applications can then query the analytic views instead of trying to code all of the various sources. Another way of thinking about analytic views is to compare them with the standard relational views. While you can certainly create a standard view that returns just about any data, aggregation, calculations, and so on, let's look at what is easy and what comes for free with each. Both can select from tables, other views, external tables, and so on. Both can join dimensions and fact tables. Only analytic views define calculations using business model-based syntax that works at any level of aggregation and across any dimension. Include system-generated hierarchical columns that simplify SQL generation, automatically return multiple levels of aggregation without multiple passes, unions, or other complicated SQL, automatically expand filters to access data for prior or future periods, parents, ancestors, children, and descendants, automatically densify time hierarchies for time series calculations, and automatically order calculations. Here are a listing of the various PL SQL packages available to be used with analytic views. Here are a list of the permissions with analytic views. Here are the data dictionary views for analytic views. The great part of analytic views is that they have descriptive metadata. You have the ability to have descriptive names, measure formatting, and its user and application extensible. So not only are you getting consistent calculations, but descriptions and formats as well. Let's take a look at an example. If you wanted to look at health insurance coverage rates in the United States, the analysis could include coverage rates by time, counties, and states. It would need to allow for geographic comparisons, measure improvement over time, and interactive data visualization tools for end users. With analytic views, the application could be quite simple, just 5 SQL statements using 2 hierarchies and 1 analytic view. Data could be leveraged by most any application, and it's all stored in the database. Let's take a look at one of the SQL statements in more detail. First, the fact data is selected from the analytic view. So we pull %insured from the insured_AV. Notice we didn't have to specify how to do the calculation. Also, that data is not stored, it's calculated. If you have ever worked with hierarchies, notice we just specified the dimensions for the query without joining or grouping by. Again, making this very simple to just state what levels you want the data to be returned. We just stated hierarchies and the time and geography hierarchies. The member_name syntax makes it much easier to select instead of trying to figure out the various columns you would need from the hierarchies. Instead of trying to do various group by and joins, you can just specify the level in the where clause. Since the data is calculated and not stored, you can quickly adjust the level and let the Autonomous Data Warehouse quickly determine the new values. If you wanted to drill further, you just specify a different level instead of rewriting the SQL statement, making parameters much easier to pass in. No longer do you need to know the format for a calculation. You can just select a column and the database will process the data accordingly and return the result. If you want to dive deeper and get a chance to try our analytic views, you can go to livesql.oracle.com and try out the tutorials yourself. How to use machine learning. One of the features that comes with the Autonomous Data Warehouse is Oracle Machine Learning. Let's look at how you can use Oracle Machine Learning. Oracle Machine Learning, or OML, is a SQL notebook interface for data scientists to perform machine learning in Oracle Autonomous Data Warehouse. OML is a good tool that allows collaboration on building, evaluating, and deploying predictive models and analytical methodologies. In the Autonomous Data Warehouse, changes made by one user are immediately updated for other team members, allowing for simultaneous collaboration. There are 30+ parallel and scalable built-in machine learning algorithms available to be used out of the box. When using Oracle Machine Learning, there is a set of steps that need to be completed in order. Some of these steps are done behind the scenes with defaults, but they can also be done manually. We will go through these in more detail. The first step is to create a user login. This can be found in the Service Console of your Autonomous Data Warehouse. You have the ability to log in as admin, but you won't really be able to use OML as admins since it cannot create notebooks. The best approach is to create a new user to log in as. After creating the user, you will need to log into the Oracle Machine Learning. The first option is to click on the button on the same screen you used to create the managed OML users. The second is via the email you received when you created your OML account. The third would be if your admin provided you with a direct link to OML. A workspace is an area where you can store your projects. Each workspace can be shared with other users so they can collaborate with you. For collaboration with other users, you can provide different levels of permission, such as viewer, developer, and manager. You can create multiple workspaces. By default, you will get a workspace created for you. You can manage the workspaces as well as permissions via the drop-down menu. When mapping workspaces, you can edit them and change the name or add a comment. You can delete the workspace, or you can change the permissions on the workspace. When managing workspace permissions, you select the user and then give them one of three roles. They can either be a manager with the ability to access the workspace but create, update, and deleting projects and notebooks. A developer with the ability to access a workspace and project but create, update, and delete notebooks, or a viewer with access to workspaces, projects, and notebooks. Keep in mind, any changes made in the workspace, project, or notebook will be reflected immediately. A project is a container for organizing your notebooks. You can create multiple projects. Permissions cannot be assigned at the project level, only at the workspace level. By default, you will get a project created for you. You can manage your projects from the drop-down menu. When creating a project, you can give it a name and choose a workspace for it to reside in, as well as a comment. The project will inherit the permissions from the workspace it's placed in and can only reside in one workspace. Oracle Machine Learning uses Zeppelin Notebooks, a collaborative interface where you can write code, equations, and text, create visualizations, and perform data analytics. Notebooks work with interpreters in the back end. In Oracle Machine Learning, notebooks are available in projects, where you can create, edit, delete, and even notebooks as templates. There are two ways to create a notebook. First, you can just click on Run SQL Statements or Scripts. This will give you a scratchpad to get in and start using OML. When you're done, you will be able to save them by going under Notebooks and drilling in and clicking Save. The second way to create notebooks is to click on Notebooks and then Create. A notebook is separated into two sections. The top is the editor and the bottom is the output window. The editor is where you put your SQL statements and run them. The output window is for results of the SQL statement. You have the ability to create multiple editors and result windows in a notebook. This comes in handy when looking at multiple data sets. At the top of the editor, there is a bar with multiple icons on it. This bar allows you to run the statement, hide the code editor, hide the output screen, clear the output, clear the notebook, and export the note. In the output window, there is a bar that has several options available. You can change the format of the output between table, bar chart, pie chart, area chart, line chart, and scatter chart. Also, you can export the output to CSV or TSV. When working with a notebook, you can export it to a JSON file and move it to another database and import it. If you click on the Export button, you will get prompted to save the JSON files. Save this to a location on your computer. To import a notebook, go to your notebooks and click on the Import button. Find your JSON file that contains your notebook. When finished, you will see the notebook was imported successfully and it will appear in the window. Now let's look at Analytics Cloud and data visualization. Two of the most common tools to use the Autonomous Data Warehouse is the Oracle Analytics Cloud and Data Visualization Desktop. Let's take a look at how to set up these tools. Oracle Analytics Cloud provides the industry's most comprehensive cloud analytics in a single unified platform, including everything from self-service visualization and powerful inline data preparation to enterprise reporting, advanced analytics and self-service analytics that deliver proactive insights. With support for more than 50 data sources and an extensible open framework, Oracle Analytics Cloud gives you a complete, connected, collaborative platform that brings the power of data and analytics to every process, interaction, and decision in every environment: cloud, on-premises, desktop, and data center. The confusion comes in when someone asks, what is the difference between Oracle Analytics Cloud and Data Visualization Desktop? Data Visualization Desktop, or DVD, is the desktop extension of the Oracle Analytics Cloud. If you want to quickly try out Oracle Analytics or running isolated from others in the organization, Data Visualization Desktop is a good first step. If you're looking to build an enterprise solution, Oracle Analytics Cloud would be a better approach, and then leverage DVD where it makes sense. Here are the requirements for the machine running DVD. A few things to take note. You need to run on a machine with Windows or Sierra. Currently, DVD is not supported on other operating systems like Linux. Also, the user will need admin privileges to install the application. Now, when using DVD, you may need additional memory and disk space as you work with larger datasets. These are just the minimums. To create an Oracle Analytics Cloud instance, click on Analytics, which will bring you to the Analytics Cloud page. Then click on Create Instance. Creating an Oracle Analytics Cloud instance is relatively simple. You just need to specify a name for the instance, then which region you want to run it in. It's best to keep the region the same as where your data is stored, so you're not traversing the network each time you run a query. Then select if you have licenses or need licenses as part of the service. The next two options we'll cover further in the next few slides, but they are edition and feature set. Then specify the number of OCPUs you need. That's it, and you will have the Oracle Analytics Cloud instance. When choosing an edition, here are a few things to keep in mind when it comes to feature sets. Standard edition includes just data visualization. Essbase includes both data visualization and Essbase. Enterprise edition includes data visualization, Essbase, and business intelligence. You can see here a highlight of what is included in each feature set. Data visualization gives you access to prepare and explore your data across your departments or organization. Business intelligence includes everything data visualization has, and then adds additional advanced features like pixel perfect reports, day-by-day, enterprise data models, and many others. Essbase is looking at scenarios-based and what-if analysis. For a full listing of features, or if you are interested in learning more about these, visit the Oracle Analytics Cloud documentation. When you are on the Oracle Analytics Cloud instance page, you will see your instance. If you click on the name, you will get the overview screen, which will have some important information about your instance. However, if you're looking to log into your instance, you will want to go to the menu on the right and choose Oracle Analytics Cloud URL. This will bring up your Oracle Analytics Cloud homepage. Let's look at connecting to Analytics Cloud and Data Visualization Desktop. Now that the tools have been set up, let's look at how we can connect them to Autonomous Data Warehouse. On the left is a screenshot of Oracle Analytics Cloud, and on the right is Data Visualization Desktop. Once both products are installed and running, you can see from the Create menu, both tools have some of the same functionality and look. When connecting to the Autonomous Data Warehouse, we will use the Create Connection, Dataset, and Project features. Since the screens and workflows for what we will do will be almost identical, we're just going to look at OAC. You can use the same steps for DVD. To create a connection, click on the Create button, and then click on Connection. You will see there are many more sources than just the Autonomous Data Warehouse. But for today, click on Autonomous Data Warehouse. There aren't many settings needed to create a connect. First, specify a name of the connection you will be using when pulling objects from the Autonomous Data Warehouse instance. Then provide the client credentials. If you already extracted the wallet, then just specify the cwallet.sso. If you specify the zip file, it will just put the cwallet.sso from there. Then supply the username and password to a user that has access to the objects in the database. For service name, the dropdown will be populated from the service names available. Choose the correct service name based on what you learned from the monitoring module. To import objects from the Autonomous Data Warehouse into Oracle Analytics Cloud, click on Create Dataset. Then, select the connection you created earlier. If you skipped a step on creating a connection, click on the Create Connection button and follow the screens to create it. Then, continue. After selecting your connection, you will be presented with all the schemas your user has access to. Click on a schema and you will see a list of tables under the schema your user has access to. If you didn't see a specific schema or table, then the user you specified in your connect needs to get access to that object. Once you select the table, you will be presented with the columns on the left. You can select specific columns or click the Add All button to select all the columns. You will see the columns get moved to the right side. If you wanted all but one column, then you can add all, then go to the right side and select the specific column and choose Remove Selected. At the top of the window, you will see a name box. This is where you specify the name of the object you want created in Oracle Analytics Cloud. It can be different from the table name and should be meaningful based on what it represents. Once you name it, click Add. After adding the object, you will get it added to the Data Elements window. Each of the columns will be on display at the top, and at the bottom will be the details about the specific column. Remember, when working with numbered data types, that you need to review the treat as attribute. If it's set to measure, then it can have function applied, but it cannot be used to join. So if it's an ID column, make sure to change the treat as or change the data type. Once you have done that, you're all set to use it like any other element in Oracle Analytics Cloud. Here is what we covered today. We started by describing how to use ADW with third-party software, then describing how to build analytic views, and explaining how to use Oracle Machine Learning. And finally, we explained how to install and configure Oracle Analytics Cloud and Data Visualization Desktop, and how to connect them to the Autonomous Data Warehouse service.